Assalamu alaikum, I am Meera Mudassir and today I will talk about the applications of nanotechnology in paints and coatings. First of all, we all know that paints are the complex mixture of substances which are applied on different surfaces like the concrete surface, brick, wood, stone, etc. And the type they are used, for example, if they are used for the decorative appearances, then they are modified accordingly. There are two types of paints. First are the oil-based paints and second are the water-based paints. So the nanomaterial improves their functionalities by making them UV protected or enhancing their antimicrobial properties. Nanomaterial improve the properties of paints because of their size, shape and greater surface area. The most commonly used nanomaterial for the paint industry are the titanium dioxide, silicon dioxide, silver, zinc and many more. This table describes the benefit of using nanomaterial in paints. Let us talk about the effect of nanomaterial on paints. First, if we talk about the titanium dioxide, it exploits two properties of the paints, that is the photocatalytic activity and the UV protection. If we combine the photocatalytic property along with the hydrophilicity of the paints, then we obtain the self-cleaning effect. This means that the paint no longer need regular self-cleaning as the water and dirt will no longer stick on it. And other than that, the nanotitanium dioxide provide UV protection to the paint. Using silicon dioxide, it provides the micro and macro hardness and enhance the abrasion properties, and likewise nanosilver provide antimicrobial properties to the paint. Secondly, if we talk about the nanotechnology advances for the functional coatings, then I will discuss three things, that is prevention against the fingerprint, smudges and fogging. If we nanocoat the stainless steel surface, it provides two things. First is the prevention against the fingerprint on the steel surface, and second is the protection of metal from the harmful effects of greasy films. This is due to the two reasons. First is the small surface area of contact. This happens when the particles are integrated into the coating and they settle on the surface of the stainless steel. The surface of the steel becomes rougher and its surface area increases. So when a finger comes in contact with the refrigerator door or any other steel surface in which nanocoat is applied, it only touches the raised points on the surface and the grease on the fingerprint don't reach the stainless steel surface. This means that the surface area which actually comes into contact with the grease is kept very small. The second is the adjustment in the refractive index of the coating. This is done when the refractive index of the coated has been adjusted in such a way that it matches the skin's natural oil content. This results in the fingerprints that are hardly noticeable. Another application is to prevent fogging. So the researcher developed a nano coating made of gold nanoparticles with the non-conductive titanium oxide which prevents fogging on the transparent surfaces like glasses. So this coating relies on the sunlight to heat the surface. When the infrared component of the light is absorbed by this glass surface or this transparent surface, then a small part of visible sunlight is also absorbed in, and it converts the light energy into heat energy. So these tests show that when exposed to sunlight, the fogged surfaces coated with the gold nanoparticles and titanium dioxide means the nano coated glass surfaces clear 4 times faster than the surfaces which are treated with a normal anti-fog agent. The last application for the nano coatings is the anti-fingerprint formula, which improves the glass surfaces in the variety of industries. This anti-finger formula is also called the nanoprint, and it key benefits include that we can create a single thin layer which adhere to the glass surface and absorb or repel the dirt or water and the oil sweats which are present on the glass surfaces. Secondly, it reduces the appearance of the fingerprints as much as 70%, and it increases the product's cleanability while it decreases the maintenance time and cost. Thank you so much.
It's Hadi Aftab and now I'm going to discuss nanotechnology in cosmetics. Introduction. Nanomaterials for the purpose of the cosmetics can be defined as the insoluble or amorphous materials that are manufactured intentionally and varies from the size range from 1 to 100 nanometers. Cosmetic products are the products or a mixture of the substance that are placed in contact with our external part of the body like hair, nail, lips or the skin for the purpose of cleaning, perfuming them, protecting them or changing the appearance and correcting the body odors. So for the formulation of the cosmetics, nanomaterials have been increasingly used for the past so many years in the pharmaceutical industries. So these materials are also contributing greatly in the cosmetic market worldwide. So the purpose of using nanoscale size ingredients in the cosmetic products is to provide long-lasting effect, increased color, deeper penetration, UV protection, and many more. In cosmetic industry, nanoparticles are present in so many products like shampoos, toothpaste, anti-wrinkle creams, for moisturizing, sunblocks, face powders, aftershave lotions, conditioner, and many more. And the two main uses of nanotechnology in cosmetics is to use nanomaterials as the UV filters, like sunblock, sunscreens, and nanotechnology for the purpose of the target drug delivery. So first of all, we are going to discuss the nanoparticles as UV filters or the mineral use of the nanoparticles. So cosmetics that contain sunscreen are called the mineral content, and the effectiveness of the nanoparticles used depends on the size. So as we all know that protection against harmful radiations of the sun is very, very important. So for that purpose, nanoparticles like zinc oxide and titanium dioxide are used in the inorganic UV filters for the purpose of protecting the skin against the harmful UV radiations by the means of reflection, absorption, and scattering. Now we are going to discuss the nanomaterials which have been used in cosmetics for the purpose drug delivery. There are so many types of nanoparticles which have been increasingly used for the past so many years for the purpose drug delivery. The first one is the liposome. So first of all, we will look into the structure of the liposome. It is a vesicular-like structure which contains the aqueous inner core, and the outside is surrounded or enclosed by the lipid bilayer of phospholipids. They are grass, which means they are safer to use. And here you can see the structure of the phospholipids. The upper part is called the hydrophilic head, and the lower part is called the hydrophobic tail. Liposomes can be suitably used for the delivery of both hydrophilic as well as hydrophobic compounds, and the size range of the liposomes varies from 20 nanometer to various micrometers. The key component of the liposomes is the phosphatidylcholine, which has been seen increasingly used in the skincare products like moisturizer, creams, hair care products like conditioner, shampoos, due to their conditioning properties as well as the softening properties. In clinical study, it is proven that flexible liposomes have been increasingly used in the formulation of the wrinkle reduction creams, and liposomes have been also used in decreasing the fluorescence in the acne treatment.
My name is Shamsa, and now I am going to discuss application of nano emulsions in skincare, hair care, and lip care. As we all know, emulsion is a system containing two immiscible phases. Attention has been focused on emulsion with nanometric droplet size. The mean diameter of nano emulsion ranges from 50 to 500 nanometers. Depending on the droplet size, there are two groups of nano emulsion. First one is transparent or translucent, and the second one is milky. My name is Shamsa, and now I am going to discuss application of nano emulsions in skincare, hair care, and lip care products. Emulsion. As you all know, emulsion is a system containing two immiscible phases. Attention has been focused on emulsion with nanometric droplet size. The mean diameter of nano emulsion ranges from 50 to 500 nanometers. Depending on the droplet size, a nano emulsion can be divided into two groups: the transparent or translucent, and the second one is milky. The following table shows difference between macro emulsion, nano emulsion, and micro emulsion. Following are the superior properties of a nano emulsion compared to macro emulsion. It has small droplet size for uniform distribution on the skin. It has large surface area. Large surface area ensures more penetration into the skin. Modified release and drug carrier properties. Better cohesiveness. It prevents our skin from moisture. It is highly thermodynamically and kinetically stable. It has pleasant aesthetic character and skin feel. Micellar nano emulsion is called in cosmetics field micellar nano emulsion, which is oil and water nano emulsion. It has been discussed more as compared to water and oil emulsion. Cosmetic manufacturers use nanoscale ingredients to provide better UV protection, deeper skin penetration, and long-lasting effects. Being compared to other nanocarriers which were discussed before, such as liposomes and niosomes, micellar nanotechnology promotes smaller nanoparticles, better encapsulation efficiency, and it is also cheap. There are two advantages of using micellar nanoemulsion. First one is it has high surface area and has the ability to allow high concentration of active compound to penetrate the skin efficiency and create a drug depot in the stratum corneum and epidermis. And second, it possesses high thermodynamically and kinetically stability of cosmetic production. Nanoemulsions in skincare. As you all know, skincare, personal care, cosmetics, makeup products, these all contain bioactive ingredients. These bioactive ingredients give the final product special nourishing and nurturing properties. When these bioactive molecules are just added to an aqueous product formulation, an unstable mixture is formed. Nanoemulsion encapsulates these bioactive molecules, which are often hydrophobic compounds, into a nano-sized oil and water formulation, which enables the bioactive molecules to be transferred into the cell where they can enfold their properties. Moreover, they can also transfer the lipophilic active ingredients into our skin, which are vitamin E, lycopene, carotenoids, or coenzyme Q10, or simply non-alcoholic fragrances. Cannabis-derived CBD. As we have seen CBD written on many makeup products, some of which I have shown in this slide. Cannabidiol. It is derived from a plant which is cannabis. Nanoemulsions encapsulate these cannabidiol CBD into a continuous aqueous phase and make them thereby bioavailable. Bioavailability means that CBD molecules get into the cells where they can develop their beneficial effects such as anti-inflammatory, anti-aging, and skin-soothing properties. Nanoemulsions and moisturizers. Nanoemulsions are transparent or translucent, and their fluidity provides a pleasant sensorial skin feeling that makes nanoemulsions suitable for being used in fluid cosmetic products. They flow easily over the skin with no creamy and glossy coating without separating into their constituents. An example of this is incorporation of gamma-aminobutyric acid, which is a neurotransmitter with relaxing muscle properties, in nanoemulsion with the aim of reducing wrinkles. Nanoemulsions in hair care. Hair care products are not only used for washing, they are also used to provide our hair silky and shiny appearance. The moisture preservation and lubrication of hair is due to silicone oil, which is also the main component of conditioners. Silicone oil is hydrophobic, thus it is poorly absorbed by hair. To overcome this issue, stable nanoemulsions containing silicone oil have been successfully developed. Nanoemulsions in lip care. Nanoemulsions are also used in lip care, like lip gloss, lipstick, lip balm, liner, to retain moisture in lips. Silver and gold nanoemulsions are used to give color to lipstick and various modulations for long-lasting lipsticks.
Assalamu alaikum. My name is Atika Rahman and I am going to discuss the applications of nanotechnology in metallurgy. Nanotechnology-enabled metallurgy is an interdisciplinary in which both nanophysics are used to improve the physical, chemical and mechanical and chemical properties of metals and alloys. The first application is nanoparticles and steel. The properties of steel can be improved by using different nano techniques. If we take a small piece of steel and apply some stress on it, it will initially begin to crack and then result in the fatal failure of steel, which can be modified by quenching or tempering copper nanoparticles. This resultant steel can be used in the construction of bridges. The most strongest form of metal, which is known as martensite steel, even when has pressure greater than 1200 megapascal, can undergo hydrogen embrittles. To overcome this, vanadium and molybdenum nanoparticles are used to improve its properties. The second property is carbon nanotubes reinforced metal matrix composites. The aerospace and defense industry day by day are in a target to improve the properties of their vehicles, tankers, etc. So their goal is to use metals which have high strength but have low weight. So many industries have used the technique of reinforcing carbon nanotubes on metal matrix composites. For this purpose, different ball milling, molecular level mixing and colloidal mixing techniques have been used, but the most preferred is powder metallurgy along with high energy ball milling. In the ball milling process, the period is extended so that to get uniform dispersion along with the undamaged carbon nanostructures. The metals used in metal matrix composites are basically magnesium, aluminium, titanium and copper. This diagram basically explains the process of powder metallurgy. In the first step, the metal powder along with the binder, in this case the binder is CNTs, both are used to form a homogeneous mixture. This homogeneous mixture is in the form of grains, which is then transferred into injection molding machine. In this injection molding machine, the green part is injected and the molding calculations are performed. This is then transferred into a binder remover. and the binder remover, almost 80% of the binder is removed, and then we are left with the brown metal skeleton, which is transferred into the sintering part, which high temperature is given to collect all the metal powders together to form a strong metal. The third application is nanomaterials for enhancing mechanical properties of metals. We can enhance or improve the mechanical properties of our metals according to our requirement. As you know that aluminium has has good thermal and electrical conductivity, but its mechanical property like density is less than that of steel, which can be improved by enhancing by putting a nano material into it. If we take the example of aluminum silicon alloy, its mechanical properties can be improved by using different nanoparticles. The nano size materials used are basically nucleation sites, therefore they should have higher melting point so that the aluminum alloy than that of the aluminum alloy, so that it does not enter into it. To improve the properties of aluminum silicon, we have used tungsten carbide WC and titanium carbide TIC. Properties of tungsten carbide and titanium carbide: both have high hardness and have high melting point. Tungsten carbide has a high modulus of elasticity and its resistance to deformation and deflection is high, whereas titanium carbide has high fire resistance and good thermal conductivity. In this experiment, both WC in the range of 40 to 70 nanometer and TIC in the range of 20 nanometer were added separately into aluminum silicon alloy, and then these were heated by using home equipment at about 350 Celsius for 5 minutes. The product is basically aluminum powder mixed with both WC and TIC nanoparticles separately. After modification, we can see that the first table shows us the properties of WC before modification and after modification, whereas the second table on the right side shows us the properties before modification and after modification for TIC. And in the case of WC, the elongation has increased by 30% in the perimeter and by 60% in the center, whereas in the case of TIC, the elongation has increased by 20% in the perimeter and by 50% in the center, with a slight increase in the tensile strength. These micrographs shows us the images of aluminum silicon alloy before modification A and after modification B. In B, we can see that the black dots have become less and have become refined, which shows us the improved mechanical properties. Thank you so much.